Well, chaos theory. I know you have heard about it. You might recognize it better by another name, the butterfly effect. The idea that when something changes in space-time, everything that follows changes with it. Simple concept, enormous implications. But here is what almost nobody tells you about the chaos theory. It is not just a fascinating idea about butterflies and tornadoes. It is the missing key to understanding something that has confused physicists, philosophers, and curious minds for over a century: quantum mechanics. Have you ever felt like you did everything right and still could not predict what came next? That is not a personal failure. That is just physics. And once you understand why, two things happen simultaneously. Quantum mechanics stops feeling bizarre, and the way you see every complex system around you, relationships, markets, weather, your own life, changes permanently. Most people think quantum mechanics is strange and difficult because it operates at the tiny scale of particles. But the real reason it feels so hard to understand is that we were never given the right starting point. We were handed the conclusion without the journey that leads there. The chaos theory is that journey, and once you have it, quantum mechanics stops being a collection of bizarre facts you have to accept on faith and starts being the logical endpoint of something you can feel in your bones. Let's start with this, the thread that connects everything. In 1687, Isaac Newton gave humanity something that felt like a superpower. Laws so precise that scientists began to believe the future was, in principle, perfectly calculable. Know the position and velocity of every particle right now, and you could predict every event that would ever follow. Every storm, every collision, every human decision. The universe as a perfect clock. For almost 2 centuries that belief held. Then a mathematician named Henri Poincaré tried to solve a problem that looked simple. 3 bodies in space pulling on each other through gravity. Not 2. 3. He expected a clean equation. What he found instead cracked the clock open, and what was inside it would eventually explain why quantum mechanics is not strange at all. It is just the deepest version of something that was always true about reality. That is what this video is about. The 3-body problem turned out to have no clean solution. Not because Poincaré was not smart enough, because no such solution exists. The motion of 3 bodies under mutual gravitational influence is not solvable with a simple equation. The interactions are too intertwined, too mutually dependent, too sensitive to initial conditions to reduce to a formula that spits out a precise answer. This was the first crack in the Newtonian clock. Poincaré realized something that had never been clearly articulated before. In certain systems, tiny differences in starting conditions produce vastly different outcomes. Not proportionally different, completely, unpredictably, irreversibly different. 2 identical systems with the same laws, same forces. The only difference is one starts with a particle 1 millimeter further to the left. In a linear system, the outputs would be proportionally different and predictably different. In a chaotic system, after enough iterations, the 2 systems look nothing alike. The tiny initial difference has been amplified and folded through so many interactions that the starting similarity has disappeared completely. This is sensitive dependence on initial conditions. The mathematical heart of the butterfly effect. The butterfly does not cause the tornado. The atmosphere is a chaotic system where a wing beat can be the difference between a condition that develops into a tornado and one that does not. The butterfly is not powerful. The system is sensitive. The answer to how many systems in nature are actually chaotic turned out to be almost everything interesting. Weather, economies, ecosystems, the brain. The exception was the simple and the artificial. Reality, in its natural state, is mostly chaotic. The universe is no different. It is estimated that millions of new stars are born and a lot die every day. And this is chaos in its purest form, on all scales. So it's just the normal law of the universe. The person who made this concrete and gave it a name was not a mathematician. He was a meteorologist. In 1961, Edward Lorenz was running a computer simulation of weather patterns. He wanted to revisit a particular sequence of the simulation, so instead of starting from the beginning, he entered the data from the middle of a previous run and let the computer continue from there. The results were completely different from the original simulation. He checked the equations. They were the same. He checked the computer. It was working correctly. The only difference was that he had entered the initial data, rounded to 3 decimal places, rather than the 6 decimal places the computer was using internally. The difference between 0.506127 and 0.506. That fraction of a difference, multiplied through thousands of iterative calculations, had produced a completely different weather pattern. The simulation had not made an error. It had revealed something fundamental about the system being simulated. Weather is not just difficult to predict because we lack good instruments or fast enough computers. It is difficult to predict because the atmosphere is a genuinely chaotic system, where the precision required to predict long-term outcomes exceeds any measurement we can ever make, where the gap between what we can know about initial conditions and what we would need to know is not an engineering problem to be solved. It is a physical limit. Lorenz published this in 1963. Almost nobody read it. He was a meteorologist publishing in a meteorology journal, and the implications of what he had found were far larger than the field he was writing for. It took another decade for other scientists to recognize what it actually was. Not a finding about weather, a finding about the structure of predictability itself. A man checking a discrepancy in a computer printout and finding, at the bottom of it, a fundamental limit on what any intelligence can ever know about the future. Drop a comment with the word chaos if this is already shifting how you think about uncertainty, because we have not even gotten to the quantum part yet. Chaos theory is not the theory that everything is random. That is the most common misunderstanding, and it is the exact opposite of what it actually says. Chaotic systems are deterministic. They follow precise mathematical rules. Given a perfectly precise starting condition, the outcome is completely determined. No randomness in the equations. The chaos comes from one inescapable fact. Perfect precision in initial conditions is physically impossible. To predict the long-term behavior of a chaotic system, you would need to know the starting state with infinite precision. The universe does not allow that. At the smallest scales, the act of measuring a system disturbs the system being measured, which brings us to the border between chaos theory and quantum mechanics. Chaos theory operates at the classical scale. It describes systems like weather, fluid dynamics, populations, economies, systems made of things large enough that quantum effects are negligible. But chaos theory revealed something about the structure of prediction that quantum mechanics takes to its logical conclusion at the fundamental level. In classical chaos, the limit on predictability comes from our inability to measure initial conditions with sufficient precision. In quantum mechanics, the limit is deeper. It is not about our measurement tools. The system genuinely does not have a precise state to measure. The uncertainty is not in the measurement, it is in the system itself. Chaos theory was the preparation. It taught us to accept that deterministic systems can be unpredictable in practice. Quantum mechanics taught us that at the fundamental level, the universe is not even deterministic in the same way. The unpredictability is not a consequence of our ignorance. It is a feature of reality. Before we get to the bridge between chaos and quantum mechanics, one thing. Both theories describe systems in transition, where the old predictable pattern breaks down and something new emerges, where small interventions at the right moment produce what no amount of force at the wrong moment could. That is also exactly what a genuine personal transition feels like from the inside. If you feel you are in a transition right now, if you feel your life is in a difficult phase at the moment, then this is for you. I built the Quantum Transition Field Guide for that specific moment. 89 pages covering the phases of a real transition, what each one produces in the body and in experience, 5 protocols, and a 30-day navigation guide. The audiobook version is also available for those who prefer to listen. So don't waste this opportunity and purchase your Quantum Transition Guide right now. Both are in the description. Now, let's go back to physics, because what comes next is the part that changes everything. Here is the bridge that the title of this video promises. Quantum mechanics has been experimentally confirmed with more precision than any other theory in the history of science. Its predictions are accurate to 10 decimal places, and yet, for a century, the people who work with it have had genuine difficulty explaining what it actually means. Not what it predicts, but what it means. The standard interpretation says that quantum particles exist in superposition before measurement. All possible states simultaneously present. The act of measurement collapses that superposition into a single specific outcome. But what counts as measurement? What causes the collapse? Why does one outcome emerge and not another? These questions have generated more philosophical debate and more interpretational frameworks than almost any other problem in physics. The Copenhagen interpretation, many worlds, pilot wave theory, each one trying to make sense of what the mathematics is describing. The chaos theory offers something that most of these interpretations miss, a classical analogy that makes the quantum situation more intuitive without reducing it. In a chaotic classical system, the outcome is determined in principle, but unpredictable in practice, because of sensitivity to initial conditions you cannot measure with sufficient precision. The determinism is real, but inaccessible. The predictability is impossible, not because the rules are random, but because the information required to use them is unavailable. Quantum mechanics takes this further. The unavailability of information is not just practical, it is fundamental. The Heisenberg uncertainty principle is not a statement about the limits of our instruments. It is a statement about what properties a quantum system simultaneously possesses. Position and momentum cannot both be precisely defined at the same time, because the system does not have precise values for both simultaneously. That's why chaos theory is the key for that. What chaos theory gave us was the intuition that a system can be perfectly lawful and fundamentally unpredictable at the same time. That determinism and predictability are not the same thing. That the absence of randomness in the rules does not guarantee the ability to forecast outcomes. With that intuition in place, quantum mechanics becomes less bizarre, not simple, but at least less arbitrary. The universe is not random at the fundamental level. It is sensitive in the same way chaotic systems are sensitive, but at a depth that goes beneath anything classical mechanics describes. Chaos theory was the preparation that made this possible to accept. It showed us, at the human scale, that lawful systems can be fundamentally unpredictable. Quantum mechanics shows us the same thing at the deepest level of reality. The strangeness is not arbitrary. It is where the trajectory was always heading. Chaos theory shows us that quantum physics works this way, generating chaos all the time, throughout the entire universe, at every moment and on every scale. I personally find it incredible how the universe is chaotic and beautiful at the same time. If you pay attention, there's a certain beauty in chaos, and that's quantum physics. Nothing but chaos. Now, let's bring here an important comment. Someone left a comment that I want to bring in here because it connects to what we have been discussing in a way that goes beyond physics. This person wrote, "I am playing this every day." Before the word quantum was popular, after I spent 6 months in India and returned to LA, it came to me to create Quantum International Productions. I connected the dots. The logo came to me easily. This was 1981. I did my own talk show for 11 years, interviewed entertainment and sports celebrities and healing icons. I did deep consciousness journeys. I was told many healing methods from the field. I was told to practice every day, the mirror meditation. But I felt I had failed because I did not do it every day. I was told I would live hundreds of years. This teaching gives me recognition that I am quantum consciousness, and I did not fail. Thank you, whomever you are. Thank you. I hope to serve at the level of my capability with your continued guidance. What was described, without using this language, is a chaotic system. This person had a sensitive initial condition in 1981, a moment of clarity arriving from somewhere that could not fully explain. That initial condition, that seed, produced decades of work, of exploration, of feeling both connected and disconnected from what had started. The path was not linear. It folded back on itself. It looked, from the inside, like it was going nowhere for stretches that felt like failure. But chaotic systems do not progress in straight lines. They spiral. They diverge. They pass through what looks like disorder before the pattern becomes visible. You know that saying, "God writes with crooked lines"? Well, this fits perfectly here. What this person experienced as failure was the system doing what chaotic systems do, moving through the phase that precedes organization. And what was recognized in this content was not new information. It was a framework that finally made sense of the trajectory it had always been on. This person did not fail, was just in a chaotic system that was always heading somewhere and just did not have the map for what that kind of movement looks like from the inside. That's why I want to draw your attention again. If you feel you're going through a chaotic phase and need help, don't forget the guide I created, which is in the description. After all, we all go through chaotic phases and transitions all the time. If that resonates with something in your own trajectory, say so in the comments. The people who name their own version of this tend to see it differently afterward. Understanding this does not just change how you think about physics. It changes how you think about your own life. The Newtonian assumption most people still carry, that outcomes are proportional to inputs, that large effects require large causes, that precision and force are what move things. That assumption is simply wrong for most of the systems that actually matter. Relationships, creativity, health, decision-making. These are chaotic systems, sensitive ones. In sensitive systems, small actions at the right moment in the right part of the system produce effects that no amount of force applied elsewhere could match. The butterfly is not the answer. The timing is. And at the quantum level, this goes one layer deeper. The observer is not separate from the system being observed. What you bring to an interaction participates in what emerges from it. The future is genuinely open. And that openness is not the absence of order. It is the presence of a deeper order than the Newtonian clock ever described. There is a version of this story that ends with nihilism. If the future is unpredictable, what is the point of choosing or acting with intention? That conclusion gets the lesson backwards. The deterministic Newtonian universe where every outcome was fixed before you arrived was the prison. Chaos and quantum mechanics together describe a universe that is genuinely responsive, where your participation changes what becomes possible, not because you control outcomes, because the system is sensitive enough to be changed by precisely placed action. Maybe the key is not the chaos theory. Maybe the key is you. Poincaré did not set out to find the limits of prediction. He was solving an equation. Lorenz was checking a discrepancy in a printout. The insights that changed how we understand the universe arrived through exactly the sensitivity that chaos theory describes. The butterfly effect is not a warning. It is an invitation to take seriously the power of well-placed, attentive action in a system responsive enough to be changed by it. The universe is not a clock. It never was. And that is the best news physics has delivered in 300 years. Subscribe if this kind of content is what you seek here. There is more ahead that builds directly on what we covered today. Thank you for being here. If you want to continue this quantum journey, click on the video appearing on your screen right now. I will see you there, on the other side of the chaos.